keep on swimming. Focus on going fast, keeping the pace. But with every lap, the water level drops a little bit more. By the end of the hour, you are at the bottom of the pool, dripping, confused. What happened? Well, while you were swimming, the water from the pool was quietly diverted, not to water some strawberry fields, or fight some fires, or fill up another pool, but it was to cool the new data center in your city. Every year, humanity diverts 200,000 Olympic-sized pools to cool our data centers and keeping them from overheating. This is not just a staggering amount of water. It's a devastating act of what Margaret Heffernan calls willful blindness. We see the heat, we see the drought, we see the data, but we are blind to its consequences. This scale of water use should make us pause and reconsider the pace of our technological progress. But first, let's see how we arrived here. I am a computer engineer and a professor. I develop software that automatically makes computers. So if I do my job really well, in a few years, computers will be making themselves and I don't need to have a job. And I'm okay with that because if the computers are taking my job, at least they will answer my emails on time. So the brain of every computer is a digital circuit we call a chip. It is the size of your fingertip, but inside of it is like Dr. Seuss's Who Will, a bustling world of tiny little who's that turn on and off billions of times a second. These microscopic switches or transistors are turning on and off not with your finger, but with the electromagnetic field. Us computer engineers connect them to do the jobs we want them to do. Some of them add or multiply, others compare or remember. Millions of these transistors make small microprocessors, billions of them make powerful computers, and trillions of them make this digital universe that enables you to message a friend, buy your groceries online, or stream a movie from halfway across the world. And of course, each time your spreadsheet crashes, there's a few million of these little who's who have gone on strike. And it all begins with sand. We take sand and we make them into pure silicon. And then upon this pure silicon, we etch the architecture of a who will. Isn't that extraordinary? So it wasn't always this way. At the beginning, every component of a digital circuit, the resistor, the transistor, the capacitor, was connected by hand using tiny little wires on bulky circuit boards. The result was slow, unreliable, and very hard to scale. Then one day, an engineer asked a really good question. What if we could integrate everything? And that single question changed the course of human history. In 1958, Jack Kilby made the first integrated circuit, or an IC, a thin wafer that included all of the components of a circuit, a single unified structure that could carry out an entire function by itself. It needed fewer wires, it was less bulky, and it could work much, much faster. And voila, the path to the modern IC was opened. That spark of creativity made a cascade of innovations that set the pace for our technological era. And fun fact, Kilby made this an integrated circuit while everybody else in his office was on summer vacation. Proof that sometimes the best way to make an innovative discovery is to not have any work emails to respond to. So over time, we have been able to put in more and more transistors into the circuit. In the 1970s, the first Intel chip had 2,200 transistors inside of it. If each one of these transistors were a person, we had enough transistors to fill in the entire Shakespeare globe, where Shakespeare had his first plays. A decade later, we had tens of thousands, enough for a soccer field. Another decade, millions, and then billions. Today, we have built as many transistors as half of the number of stars in the whole universe. This exponential growth is known as the Moore's Law, the idea that the number of transistors doubles every 2 years. Today, my phone has over 15 billion transistors in it, and its size is the same size of the first Intel chip. So the question I'm asking you is, how did we fit 15 billion people in Shakespeare Globe? And the answer is really simple. We make them smaller. Today's transistors are between 3 to 5 nanometers. That is 4 times smaller than the smallest known virus. And my role here is to design this whole Whoville or Who universe. I make sure every tiny Who has a home, all of the roads are made, and there is no traffic. So I basically do city planning, except that if there is a road that has a traffic jam, the whole internet will start making memes about it. So in engineering term, I make the physical infrastructure of a circuit. I make sure everything works perfectly. All those Who's that need to talk live close by. The roads are short, clean, and efficient. It's a massive puzzle, but also incredibly small and unimaginably complex. And instead of doing it by hand, I'll just write software to do it for me. And I love it. I make the invisible possible, so you can watch this talk on your phone using your wireless headphones. When I see the modern IC, I see breathtaking creativity. We take the grains of sands and we make them work for us. We make them turn on and off 3 billion times a second without missing a beat. And all of these so you can watch dance videos at 2 a.m. while complaining that the internet or the Wi-Fi is so slow, all the while the transistors are literally breakdancing inside your phone. However, this is where the story becomes uncomfortable. This is where the hot sand meets the cooling water. To make sure that all of these transistors are turning on and off, they become very, very hot, like laptop on your lap during a Zoom call hot. And to make them cool, we do it the fastest way an engineer could think of. We run cold water through them. Simple. So today, data centers drink millions of liters of water every day, enough to supply a small town. And together, all of our Whovilles are so thirsty that every day they drink equivalent of 4 Lake Louises of water. And it is not just water. When we made these circuits and these data centers, we forgot about the electricity that needs to run them. Today's data center around the world use as much electricity as all of Canadians. And we also forgot what happens when these chips die. So in 2022 alone, we made enough electronic waste that if they were on garbage trucks and they lined up bumper to bumper, they go all the way around the equator. So when I look at a computer or a data center, I see 2 kinds of realities: the natural reality and the imagined reality. The natural reality is simple. It is sand, it is electricity, it is electrons, and it is electromagnetic force. Those are the raw material of my work. I bend these natural laws to make sure that sand comes alive and then the electrons turn into the rhythm of thought. But the imagined reality is just as powerful. The imagined reality are the stories we tell about what are these chips for. It is the culture that whispers what are the stories that we need to listen to and what are the problems we need to solve. These imagined realities shape our designs as much as our laws of physics do. As Tina Sealing once said, culture is the soundtrack of creativity. So let's listen for a moment. What do you hear when you talk about our culture? Well, I hear a fast single beat rhythm, left, right, left. It's a sound of efficiency. It's a cadence of marine. It is precise, powerful, and predictable. This is the beat we design by, and this is the kind of creativity we make. We make things fast, we make them massive, we double them every year, and we make them powerful. But what if we change the soundtrack? What if instead of a march, we heard Ode to Joy, a melody where that lets every voice be heard, all of them rising together towards us. Each one of them will be different, but harmonizing towards something larger, our shared humanity. If that is the sound of our creativity, if we let joy keep the pace, then we can change the soundtrack of our technology. We can change what we design for. We can stop marching and start telling those stories that never got written in our chips. Because for decades, our stories have been about speed, growth, and power. And that story gave us the internet, the social media, the cryptocurrency, and AI. But it also blinded us to their costs. And the costs are real because our natural reality is very, very clear. As the Planet Health Check 2025 report says, if the Earth were a patient in a hospital, it would be in the intensive care unit. So our imagined reality of endless growth, consumption, speed, and power is pushing us to the brink. And that brings us back to the beginning. The pool is empty, the water is gone, the tiles are drying beneath your feet. For decades, we have been going faster and faster, focus on perfecting our pace, while we didn't realize that the water levels was dropping. But we don't need to go any faster. We need to look up, notice the water level is dropping, and find ways to bring that water back. Because the signs are everywhere. The ice is melting, the rivers are running low, and the lakes are shrinking. And the forests, the ones that kept our summers cool and our air clean, are burning to ashes. And their smokes are traveling hundreds of kilometers to remind us that we have sped past the natural limits of our planet. We have drained the pool, and the nature is sending us the bill in heat, in smoke, and in fire. So let's turn that ingenuity that helps make silicon speak in zeros and one. If we act now, we can refill the pool with clean energy, shared knowledge, and restored ecosystems. So this is our turning point. We can keep on racing in circles or change the story. And yes, unfortunately, we have to do it fast this time. Because the heartbeat of planet is flattening out, the pool is almost empty, and my friends, the fire is at our feet.